Good day. Today we will continue our lecture about the method of crystallograph projection. I want to remember you that last time we have studied the three kind of crystallograph projections, and now we will tell about the gnomonic projection and the practical application of the Wolf grid. There are four types of crystallograph projections, and these types of projections are distinguished depending on the projection object and the projection plane. I hope you know the spherical projection, stereographic projection, gnomostereographic projection, and today we will introduce the gnomonic projection. This kind of projection is different from another. Here you can see the properties of gnomonic projection. The first, the object of projection is the pole complex. It's clear. The plane projection parallel to the equator and tangent to the North Pole. Angular relations are not preserved. It is very important. The coordinates of the point, the projection of the plane, are proportional to the Miller indices. And this kind of projection is used in X-ray analysis. Pay attention on the third properties. Angular relations are not preserved. Of course, it is very important, and at the same time, it is very strange because the main law of crystallography is the Stennon's law, the law about the constant angles between the faces in the same substances. But if we tell about the gnomonic projection, this law is not preserved. Of course, I have a question. Why do we need the kind of this crystallographic projection gnomonic? Why do we need in this projection if the main law of crystallography is not preserved? It turns out gnomonic projection is very important because the coordinates of points are directly proportional to the Miller indices. Now we can prove this by this slide. Look here, please. ME is the track of the plane of gnomonic projection on a plane drawing. MI is the track of the crystal face cutting of the coordinate axis and pieces of PA and C, where P is integer. MP is the same D. The other words is D is the distance of point on the gnomonic projection from central point of the projection M. C perpendicular A, that is OP perpendicular MA and MP parallel OA. Consequently, angle OMA is the same angle AOP is the same angle MPO, that is denoting OM is C. We have the next quotient 1 derived P, 1 derived Q, 1 derived R is the same HKL, where HKL is the index of Milles. The last equation here shows that the coordinate point representing the crystal face on the gnomonic projection is directly proportional to the Miller indices of the face. This permits to define the character of the faces on gnomonic projection, and the principle of construction gnomonic projection is shown on the last illustration. I want to tell some words about the practical application using this definition of crystallographic projection and the special equipment we are able to solve the different tasks of crystallography. Wolf grid is the special grid I used to solve the quantitative problems by using stereographic and gnomostereographic projections. The most common is Wolf grid. Wolf grid is a stereographic projection of the entire system of meridians and parallels drawn on the surface of the sphere. You can see here. A projection plane is a plane of one of the meridians. Position of any point is determined by its special coordinate. Spherical coordinate phi here and rho. The grid is drawn on the disk diameter by 20 cm. The lines of parallels and meridians are drawn at 2 degrees. The distance between them is divided further into 4-hour parts. Therefore, the accuracy is 0.5 degrees. In conclusion of our lecture, I want to add that the crystallographic projection is very important instrument for comprehension and research the properties and the structure of crystal. Using the different stereographic projection, we can draw them, understand the different elements of symmetry. We will tell about them further, and the defects of crystalline structure. Thank you for your attention. Good luck.